Hi, so this is a video for COMP345 slide set number 3. There's going to be two parts, two different videos for this slide set. This is for slides 1 to 21. So this slide set is essentially about how to input and output in C++. So here we go. So here I'm going to show how to do input and output using streams, which is the standard way of doing it in C++. There's also, if you want to use C-style input and output, you can also do that. But mostly I'm going to concentrate on streams and give you some idea of how to do it also in C-style. So we're going to start with stream operators and how to enable the streams using a library in C++. So there's output to the console and input from the keyboard. There's other kinds of streams, but the basic streams that are available in the basic language are for console input and output. And then we're going to go also to files, input and output from and to files. In the second video, I'm going to present how to do MFC serialization, which is something you may have been used to do in Java very easily. Basically, this example in second video is going to show you that it's not that easy to do if you use MFC or any other serialization in C++. So C++ uses what is called streams to input and output. So the streams are defined in a library. So you have to include this library in order to use the streams. It's not part of the basic language. So you can also, as I just mentioned, you can use C-style input and output. They don't use streams, even though there are some operators that you can apply on streams. They seem to be the same operators. They're not necessarily the same. So it may use the same style, but they're not necessarily the same operators. So what is a stream? A stream is an object that is defined that allows you to interact with a device. So it's connected with operating system, and it interacts with operating system to either output something on a certain device or to get some input from a certain device, either the keyboard or a stream or the console. So these are all different kinds of streams that you have available. So you also have other kinds of streams that may be available from some libraries. For example, if you want to interact with network sockets and so on, this is not even part of the library that I will show here. So you have other libraries that may provide you with different kinds of streams. Most of them or some of them are defined in the same way as the streams I will explain here, but not necessarily. We're not going to cover how to do network streams in this course. So the IO stream objects that you most often use are CIN and COUT. There's also CR are other ones, but mostly here we're going to use CIN and COUT and also the file streams. So these are defined in the C++ library called IO stream. So anytime you want to use CIN and COUT, CIN is for inputting from the keyboard, COUT is output to the console output. So if anytime you want to use these two or either of these two, you must go #include IO stream and then enable the namespace std or standard in which the CIN and COUT objects and classes are defined. If you want to be more specific, then you can go #include IO stream using, for example, if you want to use only cout, then you go using std : cout. If you're only using cout, then these two things are the same. This allows you to be more specific about what you are using in the code that is in your file, which might be useful for your fellow programmers, your teammates, for example. So cout is an instance, an object instance of the class oStream or output stream, which is defined in the IOStream library. Same thing for cin. It's an instance of the class iStream, which is also defined in the IOStream library. So what is it that you can output? Literally, you can output anything, any kind of object, but there are some types for which the output operators, input and output operators, are already defined. If you want, as I will show later, if you want to have your own objects to be compatible with the input and output to and from streams, then you have to define your own stream input and output operators. I will come back to that later. So the way to use it, you essentially use the cout object and you use the stream output operator or stream insertion operator, which is lesser, and then you output a certain value, and then you can actually have a sequence of such operators if you want to output a series of things, for example, on the console output. So this would eventually output the value of number of games followed by the string games played. So basically the stream operator, the stream output operator or stream insertion operator is defined by default for the int type and is also defined for the string type. If you want to output something else, such as your own classes, you would have to define your own stream insertion operators. So if you want to do so, and that's one of the requirements we, if you look at the project description and the assignment descriptions, one of the things we say is that if you define a certain class in your project, you must provide your own, for all of these classes, you must provide your own stream insertion operators, which is of course very handy if you want to output things to the screen or to the console. So there's two ways to do it. So this includes, or this presumes that you understand some of the concepts that we will cover later in more details, but here it goes. So if you have a class A, and for example, that very simple class that contains a public int named I, then this is how you declare your stream insertion operator. We will come back to operators later on, but here is a kind of a template for you to follow if you want to implement your own stream insertion operators for your own classes. So this is the operator stream insertion. It returns an object of type oStream as a reference, and then it takes as parameters two objects, the oStream itself, as well as the value that you want to output, in this case, an object of type A, which is the type of your class that you want to, or for which you want to overload the stream insertion operator. What it does is essentially that it insert into this stream, which is the parameter, the string that you have here. Okay, so if you, for example, use the if you use cout to actually output an object of your own kind, then this is the parameter number 1, cout. This is the parameter number 2, which is your x, which is of type A. So that's what would trigger the execution of this operator here as this part is being executed. So eventually it returns, as we see here, it returns a reference to the stream that you are inserting into, which allows you in turn, after this one has been executed, allows you to actually output to the same stream this end of line marker here, as we will see later. So anytime you want to have your own classes implement or overload the stream insertion operator, that's exactly the same thing you should do for any of them. So it must return a reference to oStream, take an oStream in input, and then take one object of your own type as the second input. So this is how you do it as a free operator. As you may see this operator here, it is not a member of this class here, which you could define it as a member, but you have to implement it as a free operator if you want it to work. Another thing is here, you see that this operator is a free operator, so it's not a member of the class, but here it tries to access the member A, the member I of the class A. So that basically presumes that this free operator has access. In this case, I has been defined or declared as public, which makes it so that this free operator, which is not a member, can access this member I. If you have some private members, then you have a problem with the solution here. If that would be private, then I could not be accessed from the exterior of the class, thus making this operator invalid. If you want to make this work using private members, then what you have to do is to declare exactly the same operator, except that you have to declare this operator here as a friend of the class A. And that's how you declare a friend. We will see friends later. Okay. All this to say, if your members are public, then data members are public, you can print them, but if they are private, then you have to do the same and make the operator as a friend. Now, how do you do, for example, end of line, which is very common? So in C style, you would actually output \n, which is the special character for escape sequence character for new line. That would still work if you're doing C style. For example, if you go cout hello world \n, it includes carriage return at the end of hello world. If you want to use C style, then what you do is to output hello world and output what the object ENDL or end of line, which would do exactly the same as this here. Well, there's a little bit difference, but it does not appear very often. So here, basically, you are outputting two different things on the stream. So if something bad happened with the first one here, the end of line might not be appearing. Whereas here, the end of line is in the same stream, the same string here. So it's less likely to create such problems. But you will not see these problems often, but sometimes you may be puzzled as to why your end of lines are not outputted, or if you are outputting something here in a sequence, more than one thing. Sometimes if outputting the first one goes wrong, then the other ones will not be appearing on the stream. These are all peculiarities that may happen in some special cases. So essentially, ENDL is a stream manipulator. So we will see later on that you may want to use other stream manipulators. So there's a lot of different stream manipulators. We will not cover them extensively here. Some of the stream manipulations you might want to do, for example, if you want to output a price. So eventually what you want to output, if the price is $78.50, you don't want to have this and you don't want to have this either. What you want to have is $78.50. Of course, if the price is a number of type double, then that's why it would end up outputting this if you are outputting the price, because price is a double would output this or this, depending on what compiler you are using. So if you want to output exactly 2 digits after the dot, then you have to instruct somehow the stream anytime it outputs a double to use a certain format, which is expressed using stream manipulators. So the way to actually do this in this special case, this is just one example among many other examples. Again, not gonna go into all the details of all kinds of stream manipulators, just an example. So you would actually instruct cout to output a fixed number of digits after the dot, and then always show the point. For example, if the value of price is 78, then if you if you output the price on the console, it might just output 78 and not 78.00. So that instructs the stream, if it is to output a value that happens to have 0 numbers after the dot, to always put the dot. And then this last one here instructs the stream to always output 2 digits after the dot. Okay. So then if you set that, you send these stream manipulators to the cout, then ever after, when it's going to output a floating point number, we'll always use this stream specification. Thus here, it would actually output always in this format here, which is what you want. All this to say, there's a lot of different stream manipulators. We'll not cover them in details, but you should be aware that there are such manipulators, and if you have to use them, you have to research them for yourself. So that was for a very brief introduction for console output. If you want to do keyboard input, then you would use CN. So CN is an object instance of the class iStream that is defined again in the IOStream library. In this case, if you want to extract from the keyboard, then you would have to use the stream extraction operator, which goes it's greater rather than lesser, expressing the fact that it's extracting rather than pushing. So you would write something like this, for example, to extract a value from the keyboard and then put it in your variable, which should have been previously declared, the variable named num. Assuming this would be an integer, then the user would then enter some digits and then press enter, and then these digits would be all figured out as an integer that would be now the value of num after the execution of this statement here. So that's pretty easy. Well, that can actually go wrong. For example, what if your input, you go C in num, assuming that num is an integer, somebody enters their name and then presses enter. Well, that will, of course, make the operation fail. Depending on what compiler that you are using, it may actually do nothing up to throwing an exception. So if you want to make your program robust, then you should actually include some code that will trap these cases, and then, for example, ask the user, oh, you enter something wrong, and then ask for entering again. So this will not be done by default, of course, by the operation. You have to put code that will deal with these cases. You could also use the C-style function and operators. So for example, you can go get line from an iStream that will actually get a line from an iStream and then output it or store it into a variable named string. So you see that here the getLine function that used to be a C function has been overloaded to actually work with the streams. So getLine used to be a C kind of thing which did not use streams, but it has been overloaded to actually work with streams. Same thing if you want to get a single character, then you specify from which stream you may want to get it and the variable in which you want the character to be put. You can also use some of the operators can be used directly from for example, the CN. So that would essentially be doing the same thing. So these are different syntaxes that you can use. They are not going to behave exactly the same because they are implemented using different code. There is some different possibilities. You have to be aware of what are the particularities of each of them as you use them. Now that was for outputting to the console and inputting from the keyboard. Now what about if you want to read or write from files? Which is one thing that we're asking for you to do in first assignment. So that's very similar. So these reading and writing from a file is same concept. It uses the notion of a stream, which is exactly the same concept as the CIN and the COUT, except that these will be file input and output stream. So if you want to do file input, you have to use what is called an IF stream. If you want to do output, you use an OF stream. These are part, or these are file streams, hence the F. So these are part of the library F stream and not IO stream. So if you want to input output from a file, you must hash include F stream. So they are a little bit more complex because, as you may know, when you read or write from a file, you may read or write from different kinds of files in different modes, okay? So you have to specify what kind of file that is, depending on what method you use to actually open your files. So depending on what mode you are also using, you may have to use different operators. So depending on what you are using, there might be some differences. Here I'm directing you to one of those ways of using the F streams. There are others, I'm not covering them all here. Because they use stream, the OF stream and the IF stream, because they are streams, they also have their operators overloaded. The stream insertion and stream extraction operators is assumed that you use them to actually read and write from files or to files. You can also use the C-style functions to read and write from files or to files. So for example, you can use the get C-style function. So in this case, you would actually use an IF stream, and you declare that this IF stream is connected to this file here, and then you can go exactly like you used to do in C, input.get, which would get a single character from the file. You can also write a single character to a file by using the .put file, the put file that has been overloaded to work on streams. So in the strict C language, you did not have streams, but you used to be able to call get and put. They have been overloaded to work on streams. And then you can read an entire line from a file by using getLine. So this is just some of them. There's many others. Again, not going into all of them here. So in order to read and write to or from a file, you need to open the file before you actually read or write to the file. There are two different ways you can achieve that. First, you must connect the file. Well, first you must declare your object that is going to be the file stream. Let's say you have an output file stream. This is the name of your variable. Here you declared an output file stream. Then you must open the file. Basically, you specify that you want this file stream to be connected to a specific file. So that's how you would open this file. Note that if you open a file, that actually has a consequence in the operating system. Operating system will then lock this file. So if another process tries to access this file, file will be locked. That's one reason why if you don't close the file, then the file will stay locked. Okay. So that's one thing you have to be careful about. You should always, when you open a file, you should always close the file. You don't want the file to remain locked. Okay, so if you, and that's basically here, you can actually combine these two things here into one line. Here you declare and then you open. You can also, if you pass directly as you declare your variable, you pass this string here, which is a file name, then that single line here will do the same as these two here. This is essentially calling the constructor of the OFStream library, whereas this would be calling the default constructor, which is creating a file, but creating a stream, but it's not connected yet. This creates the variable and then connects in one single line. And then you can do exactly the same if you want to. So that was to open the file in output. If you want a file in input, then you use an ifstream, okay? And that's basically the same syntax. If you want to use a file, and sometimes you use it in input, sometimes in output, then you can use an fstream. Then the additional difficulty here is that you have to specify in what mode you are opening the file as you are opening it. So you declare here an fstream that can be in either input or output. That's why you don't have ifstream or ofstream, it's just fstream. Then as you open this stream, which it doesn't know if it's input or output, you have to specify here. You have a specifier that you pass as the second parameter to specify what mode you want to open the file. There are a lot of different file modes, different kinds of files you might want to open, in what mode you want to read and write into this file, as well as whether you're reading or writing. So that's the syntax for that. So that's only when if you want, that would be in cases where you want to sometimes read and sometimes write in the same file in the same procedure. So these are some of the output file, the input and output file modes. So there's in, out, there's append, and there's many others. Those are only some of these. So depending on what you're trying to do, then you may want to be aware of what or use the right file modes as you are using your file. Again, not going to go into all of them here. As you are using them, you have to make your own research as to what file mode you should be using. So this is a little piece of code here that is basically outputting, creating a file in output or an output file stream, connecting this file stream to the file named scores.txt, and basically using this stream here and outputting some values inside of the file. So here it's outputting strings, and then it outputs an integer here. Okay. Again, if you want to output your own objects to a file, then you would have to provide the implementation of your output file stream operator or input file stream operator if you want to read from the file. So here, this is for reading from the file. So here you create an ifstream connected to this file scores.txt, and then here you essentially output values to the stream and hence to the file. Then very important, when you're finished, you have to close the file. Is basically, okay, so if you want to output to a file, or input from a file, then it's possible that you want to input from the file until the file has come to the end of the file. So you can use these file modes here, like .eof, as a marker, as a state for you to actually stop reading or writing when the file has come to the end. So there are different states. For example, EOF was the one I was using in the previous example. There's also fail, there's bad, good, and clear. These are all bits that are set inside of the stream. You can test for these bits whether they are true or not, which will actually allow you to have some conditions for you to continue reading or writing. Sometimes also you may read into a file that has not been properly opened, then the stream would actually have a bad bit that has been set, which may allow you to check if you actually did a wrongful operation. and then trap these cases, and then have some code that will be robust according to all the wrong things that may happen as you read or write. So this is just a simple example here that I designed. So it's creating a file, and then it's writing into the file. So you see that here after it wrote that into the file, everything was fine. And then here, as I'm reading into the file, then eventually I'm reaching the end of the file, showing that the EOF bit was true, which allows me to potentially stop reading. Because if you reach EOF and then you continue reading, then you're going to have the bad bit that is actually, or the fail bit that is going to be become true. And then the operation will fail, okay? Which happens in the third thing that I'm trying to do here. Sorry, here. Okay, so all this to say that you have to use these states, the stream states, to very often direct how you're reading or the process of reading, especially if you have to read repeatedly from a file. You have to stop before you reach, you should not continue reading after you reach the end of the file. So that's the end of this video. Thank you.